Okay, so this time we'll look at another example in determining if a function is continuous or discontinuous. And we pick letter C. F of x is equal to x squared minus 1 and then x squared minus 4x plus 6. Note that the function or the expression x squared minus 1 will be used when x is less than or equal to 1, and we use x squared minus 4x plus 6 if x is greater than 1. We call this type of function piecewise function. Okay, if there are two, sometimes there are 3 or 4, could be more than 2. Okay, so if this is a question on continuity, first we need to check where is the possible discontinuity. And you will see that number from the stated domain. It could possibly break at x equals 1. Okay, so we will be testing, is it continuous at x equals 1? Then we perform the 3 steps in determining if the function is continuous or discontinuous. Condition number 1 is the value at 1 should exist. F of 1 should exist. Now, how do we select between x squared minus 1 and x squared minus 4x plus 6? You may equals a 1. The function that includes, or the domain that includes x equals 1, and that is x squared minus 1. So f of 1 will be evaluated as 1 squared minus 1, 1 minus 1, or 0. So the function exists. Then we proceed to the number 2. We will be checking whether the limit as x approaches the 1, the possible value for discontinuity of the given function. Whenever you do step number 2, especially for piecewise functions, always get the limit from the left and from the right. Okay, it's always necessary. So to get the limit as x approaches 1, we will investigate what is the limit as x approaches 1 from the right and the limit as x approaches 1 from the left. From there, you select which function will you place as x approaches 1 from the right and 1 from the left. So on the upper limit, which of the two functions should be placed? Is it x squared minus 1 or x squared minus 4x plus 6? X squared. You have to decide. 1 from the right.
4x.
Yung 4x kasi greater than 1. So x squared minus 4x plus 6. And then the other one is x squared minus 1. And we will see if we will get the same number. The limit, if we do the substitution technique, that will be 1 squared minus 4 times 1 plus 6. And this is equal to 3. The other one, 1 squared minus 1 is 0. The limits are not the same, they're not equal. So actually, the limit as x approaches 1, the exact number of the function, does not exist. So number 2 failed. There's no reason for us to check number 3, because automatically you cannot say something that exists and does not exist will be the same. Okay, so the conclusion is it is discontinuous at x equals 1. So what type of discontinuity? when they are approaching two different numbers. Is removable, essential, essential. And then after essential, what type of essential discontinuity? It's a jump, di ba? Magkaiba ng number. So essential, and to be more specific, this is a jump discontinuity. Okay? So that's how you deal with the piecewise function in terms of discontinuity. Okay.